Hello, everyone. So this is a continuation of our sort of the ongoing discussion we started last week about data manipulation in R, and in particular, what this video is about are conditional statements. So if that doesn't mean anything to you now, that's totally okay. We will, by the end of this video, and once you've had a chance to practice, you'll be fully up to speed on that. The basic idea of conditional statements is you are setting conditions, as the name implies, for when R does certain things. And so a set of functions, we're going to go over two sort of basic ones, but more broadly, just in R and in computing in general, conditional statements are when you say, if something here happens, do this. If something else happens, do that. If this condition is satisfied, proceed, right? So rather than just running something or assigning something, you set conditions under which something runs or something is assigned. And so conditional statements are really powerful because they allow you to build flexible code and programs so that if you encounter a certain kind of data output, you can do one thing automatically, or if not, you can do the other, so that you can sort of process complicated data and say, if you see this type of observation recoded as this, if you see this type of observation recoded as that. And so sort of the possibilities are endless. What we're going to focus on is sort of understanding sort of a couple basic operations that lay the groundwork for basically any kind of conditional statement you might be interested in. So to start with, let's go ahead and load our tidyverse package. And then I'm going to use the read_CSV command to read in one of our sample data sets, in this case, portal_data_joined.csv. Note that I'm using the read_CSV, which is just the tidyverse version of read.csv, but you can use read.csv as well. It just won't show up with a tibble. So we get all sorts of information that reads out when we read in that CSV. Let's just go ahead and ignore that for now. So the first function we're going to learn here is the if-else function. The if-else function, as sort of the name implies, is a conditional where you say, if this, do that. And actually what I want to do is I'm not going to use the if-else function first, because I actually think to understand what's happening with if-else, it's helpful to learn conditionals more broadly. So R has has some built-in behavior, just like when you type in a function and it turns a certain color, or when we use the piping symbol, the %sign, $% that turns a different color. R recognizes certain words you can type as special things as well. So a couple of those are if. See how I typed if and it turned orange? Else is also a special word, and turns out from and a few others are, oh, from didn't show up. Never mind, don't worry about that. I thought it would. We'll talk about that later, perhaps. So let's focus on if else for now. So essentially what's happening in the if-else function is it's combining those two special characters, and it's just putting it all within a very nice, neat function. So what the if command does is we can say if, and then we're going to open up a set of parentheses, and we're going to set some sort of condition that can be either true or false. So to make one up, let's survey the survey's data frame. So if I call head on that survey's data frame, this is simple. One of the years that's available is 1977. So we can set a very simple conditional like if surveys year equals 1977. And now here's where it gets slightly more complicated. At the back end of the if statement, you have to say what to do if that thing is true. So if an observation in that survey's $year vector equals 1977, what do you want to do? Let's say print year is 1977. This is a truly stupid example. Now this isn't going to quite work. I'm going to run it and explain why. So if we simply run that, what happens now is R runs it. It prints year is 1977 once, and then it gives a warning message, and it says the if surveys $year equals 1977, the condition has length is greater than 1, and only the first element will be used. So that might seem kind of opaque at first, but what that's telling us is that the if special function here, the if conditional, is not a vector-wise operation. And so what it did here is it was looking for one value, and it asked, is this value true or false? And then it printed the thing. But we actually fed in a whole vector. And we can view that if we just run surveys $year equals 1977 in your code or console, you can see it's a whole Boolean vector of trues and falses. And so what that warning symbol is it says, hey, I'm not built to take a vector of trues and falses. I only look for the first true or false. In this case, the first observation was true. And so it said, hey, that's true. It printed years 1977. It was done, and it gave you the warning sign. So we need to think about how to build some sort of loop. And I'm not going to get into looping now to teach you how to do it, but essentially what the idea of a loop would be here is to make this type of function work, you would want to iterate or cycle through every observation in the survey's $year vector and say, is this 1977? Is that 1977? Is that 1977? And then print out some sort of result. So that's why the if-else function is powerful, is it essentially vectorizes that operation on its own. So we can try if-else, and now R should give you a little pop-up that says, hey, there's 3 things to satisfy in this function. First one is test. What is the actual test we want to do? In this case, our test is surveys $year equals 1977. Now it has yes and no. What's going on there? So a conditional really only matters if you say, like, what do you want to do when the condition is satisfied or not? So in this case, let's say what we want to do, if yes is print year is 1977, and then if no, print not 1977. So so what's going to happen here is the if-else function is going to iterate through that vector of Booleans that we create when we say, is each observation in surveys $year 1977. Each time it finds the answer is true to that test, it's going to print year is 1977. Each time it finds the answer is no, it's going to print not 1977. Let's run that. Okay, so you can see here we have a bunch, or you can visualize or read off in your console. We have a lot of not 1977s because most of the years aren't. We have a few cases where the year is 1977. Again, this is obviously kind of a silly example. What I want to show you that when the back end is what's happening with the else. So the else is essentially the no condition in if else. So what I showed you first was essentially the yes. So if surveys $year equals 1977, print year is 1977. The way R handles an else outside of sort of this handy if else function is you type else, R recognizes, hey, that's a special thing. It turns orange. In my console, it might turn a different picture in your script instead. This time, since we already had the test, we don't need the parenthesis. We just need the squiggly brackets because the test came with the if call. We said, if yes, do this, and then else, squiggly brackets, and we'll say other year. So if we run that, we're going to get the warning symbol again, the warning message, because again, the if-else functionality is not built for a vector. In this case, it's going to print year is 1977 because that is true. If we said year is 1978, now it's going to print other year because that first observation is 1977. So again, this is like the long form. You could imagine circumstances where you would want some sort of complicated loop that's iterating through things. If else just sort of collapses that for us and it handles the iteration without having to build a loop. There's still a loop hidden in that function somewhere, but part of the advantage then is it's encoded in faster programming. And in fact, I think if else probably uses C++ or something like that. And so if you're doing a large operation, it's very fast to use if else versus building your own for each item in this vector if else type test. So let's test this on the example that's shown in the actual lecture materials. So in this case, let's say we wanted to group animals between small and big. And so we're going to say that the gap for small and big is a hind foot length of 29.29. I don't know what units that's in. Maybe it's millimeters or centimeters, sure. So what we're going to say is if else, the test is surveys $hindfoot underscore length less than 29.29. If that is satisfied, if the value observed is less than that number, we're going to return the character string small. If it's not satisfied, we're going to return the character string big. So before we assign that, let's just run that function. You can see what happens here, or you can read what happens here, is you get a vector of values. Some are the character string small, some are the character string big, and then some are NA values. So those would be cases where there was no number observed in the original hindfoot length vector, and so the condition can't be evaluated. If it's an NA value, it's not less than or more than 29.29, so you get sort of a weird result. But so the value here is you can actually assign this vector as a new column name. And so that's what the code below in the lecture does, is it runs that if-else function, produces a vector of big and small factor values, or like character string values, and then it assigns that as a new column, surveys $hindfoot_cat, short for category. And so now if we view that, we see in this case we have, or we read big, big, and then a bunch of NA values. If you call a function like tables on hindfoot cat, you can see there are about 16,000 big hindfoot lengths, about 15,000 small ones. We could do something like can make a like a crosstab is NA surveys hindfoot length. That didn't work like I was hoping it would. In any case, so that is the if-else function. One I often try, and that wasn't necessarily what I expected. I'm not going to get into why, because that could be a digression. But often I find it valuable to visualize both the NAs and the categories at the same time, so you don't sort of lose track of what's going on in there. Okay, so that's if-else. Now, that worked really well if you just have two categories, like small and big. But let's say you had a bunch of different categories. The alternative using if-else would be to actually nest a whole bunch of if-else calls. So you would do something like if-else test action A, and then you'd say if-else test action B, if-else test action C, and so on until you got to the last one, action D. That can get really wonky, a lot of parentheses, easy to lose track of. So tidyverse has a function called case_when that is essentially like allows you to nest a bunch of if-else calls. So if you fit in like this type of category, this value, this type of category, this value, so you don't have to make a big set of like nested if-else calls. So what's going to happen here, we're going to take that surveys data frame, we're going to use our pipe function, so the %, caret, %, and that lets use mutate. So we're going to create a new category called hindfoot cat. So we're just going to overwrite that one we already made, and we're going to use the case_when function, case_when, open up the parenthetical. Now we're going to have as many conditions as we need. And so what's going on here is we're going to say hindfoot_length if it's greater than 29.29. And note here, there's sort of a weird syntax that happens within case_when. In this case, it's the tilde, the squiggly sign. And so you're going to say what that's telling R is if that hindfoot length value is greater than 29.29, squiggly big, comma, and then if true, squiggly small. Let's run that and see what happens. Seems to have worked. It has created a bunch of big and small values. Let's unpack again what happened there. So we said the case_when is greater than 29.29. What's going on with the true function on the backside there? Let's look at the case_when help file. So this is one of those classic help files where you say case_when, and then you look at the help file and it's like, oh, there's just a bunch of dots in there. So read down, that means it can take a lot of things. What R tells us is a sequence of two-sided formulas. So a two-sided formula in R is actually the things on the other side of that squiggly, the tilde. And so that's what we fed in, is we fed in a bunch of formulas like true, squiggly, small. And then R says the left-hand side determines which values match this case. The right-hand side provides the replacement value. The left-hand side must evaluate to a logical vector, right? Because we're doing some sort of if-else or conditional operation. That might be confusing to you, so you can always scroll down and check out an example here. These are Those are kind of weird examples. I don't necessarily find those helpful either. I think if you keep scrolling, if you're confused, I'd scroll down. I think the Star Wars one is most similar to what we're doing here, because it's using categorical variables. Essentially, what this shows, and again, the write-up for the function isn't necessarily very clear about this, so I'm just going to explain it, and then we can talk about it again in class. I think that true. I was hoping the help file would be explicit about this, but it's just not. That last true seems confusing because we said hind foot length is greater than 29.29. If that's true, code is big. The next statement says true, then small. But we just tested for greater than and said if that's true, big. What's going on here? The last true is essentially like shorthand for any other value. So if hind foot length is greater than 29.29 big, and then you're saying basically if anything else is true, code is small. So that seems really silly, but what that actually is that's like a catch-all, right? Because you can imagine, let's say you had 20 different species and you essentially wanted to grab a couple, like, and you wanted to group all the bears, right? And so you were saying if black bear, bear, if grizzly bear, bear, but then you didn't want to have to say if squirrel, squirrel, if chipmunk, chipmunk, if rabbit, rabbit. So what you would instead do is you would say like if black bear, bear, if grizzly bear, bear, and then you'd say true, squiggly, everything else, right? And so that way you wouldn't have to specify each one. There's a few ways you can do that with R. You could, for instance, rather than individually, you could say if the values in grizzly bear or black bear, code is bear. I'm digressing again. I have a bad habit of that in these videos, but nonetheless, so that's why it might seem kind of weird at first, but that true at the bottom is sort of a catch-all. And to prove that, we could do something. We could take this again, recopy that same item of clothing. We're going to build an item of code, not clothing. Let's hind foot, we're going to build a conditional in the middle of that. Hind foot length less than 0. Let's say less than 10, really small. And then we'll say true is small. So what that's going to say is if it's greater than 29.29, big, if less than 10, really small, otherwise small. Okay, we see the same bigs and smalls. Let's call something like group by hind foot cat, summarize, and just to test. And if you run that, what you will see, or what you will be able to read off here, is that there are about 16,000 big animals again, actually only 11 with a hind foot length less than 10, and about 19,000 that fit into the small category. Okay, so and just to confirm, the extra stuff I did there to count up, that was simply to count up how many of each of the categories we observed. You're familiar with the group by command already. You're familiar with summarize. In this case, the n function, n with the parenthesis, is just something you can throw in the summarize, and it simply says count the number. So we've talked about mean and median. Sometimes you just want to know how many there is of each category, and so that's where you can feed an n and it counts the number within each group. Okay, but getting rid of all that again. Oh, that did not work. There we go. You see the biggest problem is we have this suboptimal behavior where NA values were recorded as small. Why is that? Well, we talked about how that last true is the catch-all, where it's essentially if anything else is true, return small. That was why when we called the table, the crosstab with the is NA and the big small before, it ended up returning the no NAs because we'd accidentally like recoded all the NAs as small. So that digression circled back around. All right, so what we want to do is now build in some sort of conditional where rather than letting the NAs fall into the anything else bin, we actually code them as NAs. So in the lecture, you can see example code that shows what this looks like. So essentially, we're going to build in just 3, just like we did before, but in this case, we're going to use a special operator where so the first function is, like the first case is the same, hind foot length greater than 29.29 squiggly big. Now the second one is a test of, is this value NA, hind foot underscore length? And so we're going to say, if is NA, then what we want to return is the NA character again. You can tell this is a special character in R because it turned blue when it was typed. If you run a help function on that, nothing shows up. But if we type NA character turns blue and you run that in your console, you can see it just returns that classic NA again. So we've already built something just like this, but in this case, what's going to happen is that we're going to get bigs and smalls and NAs. Sure enough, if you run that in your console, what results is when hind foot length was observed, it's either big or small, and when hind foot length was not observed, it returns an NA. You can also futz with the order here. It should not matter. So if you put the NA first, you get the same result. I actually like to put NA first because in certain functions in R, they don't evaluate well if NA's last, because you often want it to first sort of sort on that, is it NA or not? And if so, then proceed to the next test. And so that doesn't matter for case win, but I think it's kind of good to get in the habit of dealing with NAs on the front end when you're setting up conditionals like this. Okay, so that about covers it. One other thing I wanted to show here is what happens if instead of this kind of complicated NA underscore character underscore, which you might not remember, you just feed in the NA value. You can see that turns blue or whatever special color there is in your console. And sure enough, in this case, it does not like that. So this would be kind of tough to decipher. It says the error says error in mutate problem while computing caused by error in case win. And it turns out that case win doesn't really like that NA special character value. It needs the NA underscore character underscore. I can't really speak to truly why that is. It simply just kind of is the case. It's possible it's living in the help function somewhere, but I just wanted to flag that's why previously we've talked about an NA value as just NA. You run that in your console, it returns NA. But in this case, in case win, you actually need to feed in the special NA underscore character underscore. Okay, so play around with this. Let us know what questions or troubles you have, and we will talk more about it in class. Thank you.